starting the recording now. So, all right, I think we're ready to start. Thank you everyone for joining to our Google Developer Expert session. For those of you who don't know, a Google Developer Expert is a person who is recognized by Google as having exemplary expertise in one or more of their Google Developer products. And Tanmay Bakshi today is just that. He is a LinkedIn Top 20 influencer, a best-selling author, a TED and keynote speaker, Google Developer Expert, of course, an IBM advisory software engineer, and more, only at 18 years old, Tanmay, I think.
Yep.
Most recent projects include Auto Lyricists, which is an AI-powered system designed to help songwriters generate their song lyrics, as well as Heart ID, which is an electrocardiogram-based biometric authentication system, which both projects we will be learning more about today. So if everyone can give a round of virtual applause to Tanmay Bakshi. Thank you so much.
Of course. Thank you very much, Layla. I'm super excited to get to speak with everybody today. Thanks for putting this together and thanks for inviting me to be a part. Of course, huge thank you to all the teams at all the different universities for making this possible. And yeah, I mean, let's sort of dive right into it. Layla's already given you a little bit of a sneak peek into what it is that I want to share with all of you today. And of course, it revolves around the world of artificial intelligence. Of course, I'm a Google Developer Expert for their machine learning category, and I have been incredibly passionate about machine learning for a very long time. But without any further ado, let's get deeper into that. So, I mean, as mentioned, I love working with technology. You can probably tell that I love writing code. You know, I'm definitely a developer at heart. And really, I think what I love to do sort of spans a couple different categories. I mean, first of all, of course, I love building technology and sort of applying it where I think it can make an impact. But I also really love making it so that more people can build technology themselves as well, right? So wherever I work and wherever I do things, I like to make it so that not only can I, build technology and create really interesting applications, but also make it so that more people are capable of building their own applications that solve problems that they face as well. So for example, whether that is working on YouTube tutorials or writing books, or for example, at IBM working on code patterns to show you how to use even enterprise grade technology, that's what I'm really passionate about. And before I dive deeper into the world of AI and machine learning and what I'm doing with it today, maybe it would be interesting to go a couple years back and take a look at how I started working with this technology in the first place, right? That's always interesting. So going back a couple years, back to when I was 5 years old is when I first started working with the world of technology. I mean, back then, of course, as a 5-year-old, I didn't really understand what a lot of this meant, right? I didn't know that people were paid to code or any of this. I really just saw my dad working on a computer and I was like, hey, that looks fun. I want to use this too. I want to be able to do this too. So he saw that sort of passion that I had, I guess, for technology, that sort of curiosity for how computers work, introduced me to the world of programming back when I was 5. And really, my curiosity only continued to grow, to be totally honest, right? Every time a question of mine was answered, for example, I just had more, right? And so this led me to use more sort of resources to learn. So for example, internet, different books that I had, and this led me to have my very first iOS application called T-Tables accepted into the iOS App Store when I was 9, an application to help you learn your times tables, which was actually really helpful, if I do say so myself. But building this application made me realize something else, right? And that was that I can build technology to help other people, but then why not also create the resources to help them build apps too, right? So then that's when I started my YouTube channel called Tanmay Teaches. And on this channel, I share what I learn on all sorts of different topics from, math and science in general to computing and programming and algorithms and machine learning and AI now as well. And to sort of scale up the number of people I could reach out to, of course, I also started writing books to sort of cover all sorts of different technologies, all the way from how you can start learning how to code with books like Hello Swift and Tanmay Teaches Julia, to cover in the world of machine learning through IBM Watson, and even back-end development through Go, one of my favorite programming languages. We'll be getting deeper into that in just a moment. But really quickly, there is one sort of limitation I realized pretty quickly while I was on this journey. And that limitation was kind of annoying to me, right? So back when I was 11, of course, I was still, working with technology and writing code. The Swift programming language had just been released, things like that. But I kind of felt like technology was a bit limiting in a way, right? Technology was limiting in the sense that it'll only ever do what you explicitly tell it to do, right? What you explicitly program it to do. And I kind of found that annoying, but I didn't know what a solution to that would be, right? Being 11 years old, and especially then this field being so new, I didn't know what a solution to that would be. But then one day I stumbled upon a documentary on IBM Watson and how it won the Jeopardy game show against the two best human competitors on the show. And that absolutely fascinated me, right? I saw that, and that just completely shattered my conception of what technology could do or what it was capable of, right? And I wanted to know how that worked and how I could use this sort of capability for myself. And I want to take a bit of a breather here and take a bit of a step back. Take a minute to appreciate just how much of an incredible feat of engineering this is. Right, this is back in 2011. They were able to win Jeopardy with a computer system. This is a computer system running human written code that is capable of understanding Jeopardy clues with, a skill level that's, at parity with the top human champions. And it's doing so in real time. These are clues with puns, with riddles, with wordplay, right? Even today, I think this is one of the most impressive, accomplishments with machine learning all these years later, quite literally 10 years later now. Wow, that's weird to say. 10 years later, this is still one of the most incredible achievements with machine learning technology, in my opinion, right? So this really sort of made me want to use this new capability. And that's when I started building applications powered by Watson and eventually custom artificial intelligence technology, which is probably the name you know this technology by it's a lot more common, right? Now, there are a couple sort of thoughts I have around the world of artificial intelligence, not only from a technical perspective, but also from even a nomenclature perspective, right? I don't think that a lot of the technology we use today that we call artificial intelligence should be called AI. I feel like AI is more of a user experience term. And once again, I will dig deeper into that. Really, a lot of what we call AI today is powered by really sophisticated sort of machine learning algorithms on steroids. But that's not to say that it's not impressive. As a matter of fact, I love machine learning. And even before I continue really quickly, again, the point of the session is to be interactive. So if you have any questions or thoughts about what it is that I have to share, feel free to send that in through the chat, and I'll definitely get to that soon. But machine learning technology is incredibly impressive and innovative, right? If for example, if you were to take a look at a survey by Gartner, over 72% of organizations vote machine learning as the most disruptive technology out there, right? When asked of all the technologies, which one do you think is the most important for your business today, or the most innovative? Machine learning is by far the opinion of the majority of companies. And this really fascinates me, right? I wondered for a very long time, why is it that 72% of organizations believe machine learning is the most disruptive technology out there? And I think I came to a pretty interesting answer, and I want to share it with you today. Part one of this answer is the following quote, right? It's because of the effect it can have on existing processes and the way people will work, right? So the processes that we already have and how people will work in the future. I'm not going to tell you who said this just yet. We'll get back to this, all right? Try Googling this, it won't work, but I will get back to who said this in just a couple of minutes because it's important. And next up, it's because technology in general is infrastructure, right? I don't think people focus on this enough. When you take a look at technology, obviously it's its own domain, but then technology also acts as very fundamental infrastructure for practically every other domain. I don't think I could name an industry today, off the top of my head at least, that isn't fundamentally reliant on technology to operate in a modern way, right? So technology, despite being a domain in its own right, is also the infrastructure for everything else, right? Think about healthcare and all this complex machinery that we have to help us gather data. Think about education and how we can, well, nowadays have virtual classrooms, but even in physical classrooms, right? We could have more interactive and engaging ways of teaching. In agriculture, we can automate so much more of the process and make it more efficient, spend less resources. In terms of entertainment, now we can, deprecate older methods of shooting. Like, for example, even using green screens, we can use game engines to render environments in real time and record in those environments. In terms of finance, we can trade instantaneously with millions of people thanks to technology, right? Technology is infrastructure, and we use it everywhere. And here's what's really interesting, okay? Here's a little bit of a thought experiment. So think about all these different use cases. Think about some sort of new disruptive, buzzword technology, and think about applying it in every one of these use cases. And I can guarantee to you, you will find at least a couple of places where it wouldn't make sense, right? Maybe in agriculture, it doesn't make sense to use cloud because you don't want latency. You want things done directly on the edge. Maybe this is, maybe you're applying it in specific locations that don't have good access to the internet. Maybe in entertainment, blockchain doesn't make much sense because what exactly do you need on a ledger in entertainment, right? If you're recording a movie. Maybe in education, IoT doesn't make as much sense as it would in, say, healthcare, right? But then you look at all these different use cases and you realize one thing: what's globally applicable? Right? What is globally applicable across all these use cases? It's machine learning. And you could come up with a valid, genuinely useful use case for all of these fields that integrates machine learning technology. Right? And the reason for that, the reason you can come up with all these different use cases, here are 5, for example, right, for every field that I just talked about. The reason you can do that is because machine learning is a very generic technology. Machine learning is literally just data analysis technology that's analyzing all sorts of unstructured and structured data at massive scales, right? Using algorithms that we previously thought would have been impossible to write. And speaking of data analysis, I've been able to use that data analysis capability in quite a few different really fun applications that I'd love to go ahead and share with you today. So these are, I think, some really fun apps, ones that I'm personally really excited by, in 2 very different domains that I'd love to go ahead and share. And I want to start off with one in the field of biometric authentication. It's a project that I call Hard ID. The idea of Hard ID, as you may have guessed by the name, is essentially to be able to identify people based on the way that their heart beats. So using electrocardiogram data, the electrical activity of your heart, I can use deep learning technology in order to uniquely identify you. It's honestly pretty fun. The way it works is there's, 3 main stages. Of course, the first stage is where I train my neural networks to be able to extract unique features and patterns from electrocardiogram. The second stage is where you provide new electrocardiogram data that the model's never seen before and tell it to be able to extract features from the electrocardiogram so that given even more new electrocardiogram, I can infer to try and figure out who this electrocardiogram belongs to. Right, so those are the 3 stages. The idea is that throughout the process, the model generates effectively unique feature vectors that represent somebody's electrocardiogram in this unique feature space. And again, I'll dig a little bit deeper into what that means in just a little bit. But the idea is that the further apart feature vectors are, the more likely that they're from different people. So for example, taking a look at feature vectors from me and my sister, collecting a little bit of ECG, processing it, feeding it into the model, plotting out the feature vectors, we can see that across the 2 of us, we have very different feature vectors, right? So the idea is that we should be able to get different vectors for different people. And now, how about we take a look at a demo of Hard ID in action? All right, now, this is one of my favorite demos because I'm going to take a little bit of a tangent first. Okay, I know we're talking about Hard ID, but there is another kind of biometric authentication that you probably use, at least if you have an iPhone, every single day. Face ID, of course. Face ID is ubiquitous at this point. It launched first with the iPhone 10, and that was brand new, but now tons of iPhones have it. The idea is that it's looking at your face, projecting a 3D sort of depth map onto your face, trying to identify you based off of the way you look. Incredibly accurate, but there are some trade-offs that you make putting facial authentication on a mobile device. As a matter of fact, a little while ago, one of my friends, Simone Oates-Fierk, told me completely nonchalantly that her and her sister have the ability to trick Face ID by having an iPhone trained only on one of their faces recognize the other sibling. And I was immediately fascinated by this. I was like, we have to analyze your faces now and try and figure out what the correlation is. So I went ahead and recorded a little bit of a demo. I really just couldn't help myself. Take a look at this. So if Simone tries to unlock her own phone, obviously she can unlock it. But if she were to go ahead and give her phone to her sister can also unlock the phone. But taking a look at the Face ID settings, there is no alternate appearance set up, right? There's only one appearance set up. So I thought, how funny would it be if Apple's Face ID biometric authentication didn't work on the two of them, but Hard ID did? So, of course, I had to try it out, and well, take a look at it for yourself. Given a few seconds of data from Raquel, Hard ID can successfully identify it as Raquel, and similarly, a couple seconds of data from Simone can identify her as Simone. So electrocardiogram is indeed a valid, unique identifier from a biometric standpoint. And I think it's a really fun application to demonstrate the kind of data analysis that you can do with deep learning technology that you couldn't before. So really fun applications. But despite the fact that this is really fun, I will say that personally, working with signal data, tabular data, image data, this is great. But the kind of data that I'm really interested in, the kind that I think you'd really enjoy as well, is working with language. Natural language processing has always been special for me. And the reason for that is because language isn't just built by the human brain and by humans. It goes the other way around, right? The way that we think is shaped by the language that you speak and the way that it's constructed and the way that you put words in sentences and the kinds of words that you use and so on and so forth, right? It's a two-way relationship. As a matter of fact, let's play a quick game, okay? Unfortunately, the screen share here kind of exaggerates the effect, but I think it's still going to be an interesting exercise. If you take a look at these three shades of blue, you can probably tell that A and C are the same shade and B is different. Okay, so I'm going to show you a couple different slides like this that have two different shades of blue. You're going to tell me which of the three ABC is different. In this case, quite obviously, it's B. Let's go a little bit harder, right? We have three shades of blue here, A, B, and C. You can probably tell, I'll give you a second, that C is the one that's different, right? Pretty obvious. Similarly, give that a few seconds. You can probably tell that the one shade of blue that's different here is, of course, B. Similarly, last one here. Which one's different? Once again, the screen share might exaggerate the effect a little bit, unfortunately, because compression, but you can tell that it's A, right? And we're going to keep getting closer and closer here. What's really interesting is that when scientists actually did a study determining what sorts of people are better at distinguishing between more similar shades of blue, they determined that you're actually statistically more likely to be able to keep telling the difference between more similar and similar shades of blue if your first language is Russian. And the reason for that is because there's just more words in the Russian language for the color blue. So from a young age, your brain is better trained to tell the difference between blues. It's really fascinating stuff, right? Language affects the brain, and it goes the other way around as well. And because of this, and because of the abstract and unstructured nature in which the brain actually works, we can come up with sentences, for example, that technically are correct according to the rules of language that we've sort of gone back and created in hindsight on top of the language that we already had. Like for example, we have a sentence like this one: colorless green ideas sleep furiously. Classic example of a sentence that really makes no sense, but technically it's valid, right? Like you can parse this into a syntax tree and there's technically nothing wrong with it. And once again, this is a fundamental limitation of trying to structure natural language. You know, you're not really extracting any, lexical knowledge out of it, any sort of semantic knowledge out of it. You're really just understanding syntax. But with machine learning technology, we can actually start to understand at a deeper level what these words in this structure actually means. It's pretty fun stuff. Problem now is, of course, it's hard to understand what that means in terms of what technology is capable of. What I mean by that is when we start to have machines that can understand natural language and identify you based off your heartbeat and do all these sorts of intelligent things, there's all sorts of misconceptions that spread around that technology and what it's supposed to do, right? Like a lot of people think that artificial intelligence is meant to simulate human intelligence. That's definitely not true. As a matter of fact, it couldn't be further from the truth. A lot of people think AI is solely about replacing human jobs. Once again, while that is a side effect of the fact that you're using artificial intelligence to automate some, roles that humans currently fill, that doesn't change the fact that we're not doing this solely to replace human jobs. There are entire domains where artificial intelligence simply isn't solely applicable. And at the same time, a lot of people think that AI is about surpassing human intelligence, right? Making it so that humans are entirely obsolete. None of this is true, even remotely. And it really it really grinds my gears to see news articles like this one. Right? Can artificial intelligence replace songwriters? Study on AI lyrics suggests that it's possible. It's interesting to see, especially in domains like songwriting, right? There are certain advancements in technology that have caused all sorts of news articles to say, AI is replacing developers and songwriters and really you name it, journalists. And once again, it's not. Right? These domains especially fundamentally require a sort of human creativity skill that computers lack. Not because today's artificial intelligence is insufficient for it, but because it is inherently incapable of the kind of creativity that humans can apply. So I thought, you know what? Let's roll with the songwriting example. So I built an application that I like to call Autolyricist. The idea being to augment human songwriters using machine learning technology. Now, I knew from the get-go that this was an incredibly hard task to accomplish, right? Even understanding simple music lyrics, like what you see on screen right now, is incredibly difficult. It's super challenging. And the reason for it is because you require not only an understanding of how to parse language and then understand what language means, but then also relate that to context, like human society and things that we want or need or like or don't like, slang, all these sorts of things tie into the understanding of music lyrics, right? Just understanding the second line in this specific verse here requires you to understand that sleep is something that humans need and not getting enough of it is a bad thing, and that Tylenol is medicine, and medicine has an effect on your health, and this specific medicine is supposed to help you sleep, but in this case, it's not working, and how that's used as an analogy for something else in the song. It's really complex. And it gets even deeper than that in the world of data science. You have to think not only about what you see here, but what you don't see as a human, right? There are things about, for example, this verse that a neural network would realize that you don't. So, for example, if you take a look at the gap between these two lines, right, there's a new line separator between these two lines, obviously. And that new line separator is an individual token according to the neural network. But in this case, that new line separator isn't because you're starting a new sentence, it's because there's a rhythmic sort of pause in the music. So there has to be a gap between these two lines. But the new line separator between these two lines is to start new semantic context. It's to create a new sentence. This gets way deeper than you would ever think it does, right? And this is the sort of stuff that I learned the hard way while building this project. What makes this even more difficult, as if this wasn't hard enough already, is that art is up for interpretation. Things that might not generally make sense to a neural network that was trained specifically to do common sense reasoning not only could work in this case, but sometimes are actually necessary. Like, for example, in this case, you might say, hey, can you see things with your hands? But in the world of art, not only can you let that go, but sometimes these sorts of sentences and sort of interpretations of ways you can put together words is actually what makes art art, right? So I'm really excited to have gotten to work with a bunch of really talented artists to put together examples of Autolyricist in action. And I'd love to go ahead and show you some of those examples now, at least one example. And if we have time, I'd love to show you more as well, but I'll definitely be putting links to it in the chat right after this as well. So links to some music by artists in the chat as well. I want to start off with a song called A Summertime Song by Claudia Heuser, country musician from the States. And she actually put a summertime song on her debut album, which was really fun. So you can take a listen to it it actually on Apple Music or Spotify now if you'd like. And of course, I'd love to play a quick clip of it for you now. Remember, these lyrics are inspired by Auto Lyricist and were written by the machine learning system that I've trained, as well as Claudia in collaboration. So let's take a quick listen.
Replay it over all our favorite lines. It's never my intention to unwind. Loving you is like a summertime song, cause it blazing past. Daydreaming a feeling I can't get back. Oh, a summertime song. It's never my intention to waste your time. We jumped in the deep end and lost what I was hoping to find. Replay it over all our favorite lines. It's never my intention to say goodbye. Loving you is like a summertime song.
And that was a quick clip of A Summertime Song by Claudia Heuser. Once again, I'll put the link to it in the chat in a moment, so you can go ahead and take a listen to this one, as well as another song called Take You There by Elena Coates and James Hebert, a very talented singer-songwriter and producer, respectively. And one more thing I would like to say is that, of course, when I reached out to Claudia about working on this, as you can probably imagine, her first reactions were a little bit apprehensive about using a machine to write music lyrics. And instead of me having to, play a game of telephone and tell you what her thoughts were, how about we hear it from Claudia herself? So here's a quick video clip of what Claudia's thoughts were working with the neural net.
When I was first approached about this, I immediately thought, no way. When we're writing songs, I really try so hard to pull from my own experiences of people in the room, and just try to be as honest as possible. So thinking about a computer coming up with these ideas for me, I wasn't really having it. But I'm always up for trying something new. And what I realized was it was almost like working with an open-minded co-writer who just brought all these ideas to the table. And yeah, you could sift through the ones that were crazy and not going to work for you, but it kind of allowed us to think a little differently and took one of these songs that we had started in a completely different direction. So we were able to come up and find the line, "Loving You is like a summertime song," and now we have a brand new song that I just love. Hope you enjoy it.
Those were Claudia's thoughts. I mean, as you can probably imagine, as an artist that actually puts effort into writing lyrics, hearing for the first time, hey, we can have a machine help you write your lyrics, might be a little bit concerning. Like, I don't want to, have the message and sort of like the intention behind, what it is that I'm writing sort of automated for me by a robot. That doesn't really make that much sense from an art perspective and a messaging perspective, right? But sort of seeing the process of working with the machine to help you get across that message faster, give you ideas, eliminate writer's block, that's the entire goal here, right? And in particular, what really sort of motivated me to work on this project was the creation of very large language models like GPT-3. This is something you've probably heard of. The OpenAI, GPT-3, and Codex models. You may have heard of GitHub Copilot. And these sorts of models are great, right? They are, from a technical perspective, incredible innovations. The fact that we can train models with 100+ billion parameters, nearing 200 billion, on today's computing systems, even just the networking infrastructure on which this was trained and the mathematical optimizers used to split weights across these many GPUs is incredibly impressive. But the problem with it is that people then take these neural networks that in their own right are incredibly capable in certain tasks and way overhype what they're going to do and what their impact is going to be, right? There's all kinds of articles and blog posts and videos and posts on social media about how GPT-3 is so great that it's going to replace all kinds of professionals in all kinds of domains. And it's honestly sort of discouraging to see that sort of, that sort of thought about how people believe this sort of technology is going to replace human domain experts and human professionals, even creative professionals. And so that's why I wanted to work on this example specifically to say, not only do you not need 175 billion plus parameters to be useful in a domain like this, if you're specifically training neural networks to be good at a task like this, but that also when you have these neural networks and they're built from the ground up to augment artists instead of trying to replace them, they can be genuinely useful. But as I mentioned, GPT-3 still has a place. Remember that quote that I was talking about earlier about why machine learning is so impactful? You can probably see where this is going. This quote was generated by GPT-3. I have access to the API and I use this. I asked it, sort of prompted it to explain why machine learning is the most disruptive technology. And this was one of the explanations it came up with. To be fair, it took a couple of tries, somewhere between 4 and 5, but this was a good explanation for why machine learning is so disruptive, right? So this is machine learning describing its own its own innovations, right? But what's so interesting about this is that it's crossing this really fine line between regurgitating what it's previously heard and being an original thought. Because at the same time, GPT-3 has not plagiarized this from anywhere, right? This is an original sentence. You Google this, you're probably not going to find anything, incredibly close. But at the same time, this is something that people are already talking about, right? Like I see a comment already saying it's slowly becoming self-aware. That's definitely not the case. but what it is doing is it's seeing these tokens being used together in this context on the internet, and in order to reach a mathematical objective of being good at predicting tokens and sentences, it believes that this is a good, I'm using believes, and even I'm personifying it, right? It's a limitation of language, but this is just mathematically a good completion in order to minimize its loss function, right? In order to make it so that it predicts an output token sequence that is close to what it believes should be an output token sequence according to its input. Another comment, can it do my assignments for me? I wish it could, and I might say that maybe this has been attempted before, right? But it's pretty fun to see what GPT-3 can do. But now, as I mentioned, right, the point that I'm trying to get across here is that all of this technology is being used in the field of natural language processing, right? That's how we started sort of getting into the world of auto lyricists and what I've done with this. And as I mentioned, with machine learning, we can start to understand natural language, kind of similar to the way that the human brain does. Problem is, though, that we don't know how the human brain processes pretty much anything at a low level. On a high level, sure, we understand the different sections of the brain are doing certain, are responsible for certain tasks. But at a low level, we don't exactly know how the brain processes any of this information, or what the sort of internal representation of a sentence like this would even be. And so, of course, when we don't know how we do something, therefore we can't write code for it, of course, researchers rush to the idea of, can we throw deep learning at the problem and make it figure out what those rules should be for us automatically? And this brings me to something a lot more fundamental, right? And that is, how does this deep learning technology actually work? Right? We've talked a lot about what it's capable of and where I've used it, but at a very fundamental level, right, down to an almost physical analogy, how does deep learning do what it does? And I think a really good analogy for it is the classic joke about topologists and how they can't tell the difference between a coffee mug and a donut, because they both technically only have a single hole, right? Either through the handle of the coffee mug or the hole in the middle of a donut, right? And you're probably thinking, why does a topologist's lack of being able to understand the difference between a coffee mug and a donut relate to deep learning? Well, let me explain. Imagine you have data like this, right? You have 3 different categories. This is plotting out the iris data set. You might be familiar with that if you've used it before. These 3 different colors of dots represent 3 different species of iris flowers. And where they're plotted on this graph represents different attributes of these flowers, right? And you can tell that, of course, red is very easily linearly separable from the rest of the data, right? You can draw a straight line, separate red from everything else. But green and blue are mostly linearly separable. Like I can think of one line that would only have like 2 misclassifications total, right? And here's what's really interesting. When you have data like this, where you can easily plot it out, easily draw lines, it's relatively easy to build machine learning systems to take these attributes and figure out which category things belong to, because you can literally just plot it out and manually draw these lines if you like. Massively increase the scale of the data, increase the number of dimensions, make it unstructured, suddenly that becomes infeasible. But with something like this, it is feasible. But here's the thing. I might have hidden something from you. This isn't the original iris flower data set. This is, right? The data on the left is the original data set. And try drawing a line between green and blue now. It's not going to work out that well. So the idea is this. If we already know a way to take data like it exists on the right and mathematically figure out how to classify between it, but we don't know how to do so for data on the left, can we instead figure out a way to transform the data on the left to the data on the right and then just apply our existing technique? That's pretty much the vast majority of deep learning today, right? You might not realize it, but pretty much everything boils down to this. And I'll show you how. And the way that relates to our previous analogy is you can think of it almost like if you start out with a coffee mug and you draw green and blue dots all over it that sort of intersect with each other so you can't draw a straight line on that surface in order to separate. If you could somehow mold that coffee mug while keeping the topology the same in such a way that after being transformed, you're left with a new shape, say a donut, where all the dots of the same color on different ends of the donut, suddenly you can separate them with a line, right? That's what AI is trying to do, is it's trying to take your data from some super high dimensional complex space where you can't tell the difference between things and transform that space so that data can be told apart within that space. I think that is, in my opinion, the most intuitive way to describe what it is that deep learning systems aim to accomplish. And the way they do this is pretty simple. So for example, say you're trying to classify between cats and dogs. You might feed an image of a cat into what's called a deep convolutional neural network. Sounds fancy, but it's a bunch of convolutions. It's just a bunch of like effectively image filters, kind of like you might have in a camera app, just stacked on top of one another. And then you've got a simple linear classification layer that's effectively just a single matrix multiplication and a matrix add. And then you come up with 2 different probabilities, the probability of this image being a cat and the probability of the image being a dog. And in this case, you would like the probability for cat to be greater than the probability for dog, right? And what's really interesting is if you take this entire thing and you sort of just encapsulate it into effectively one sort of function, one mathematical function, and you optimize this on a bunch of data using some sort of derivative-based optimization, gradient descent, you end up implicitly having the convolutional neural network transform your image into some kind of embedding space where after that embedding space, you can then translate the image back into a class, right? Because now what's happened is the convolutional neural network has taken your data, transformed the space. Now, theoretically, the images between cats and dogs should be linearly separable, and you should be able to tell the difference between them with a single matrix multiply. Nowhere did you explicitly state that's what you needed to do, but that's implicitly what the network ends up learning because of the fact that you optimize this as one end-to-end black box using gradient descent. And what's really important to think about here is your training objective. Once again, not nearly enough people think about this, but the training objective is what defines how your neural network learns, right? For example, in this case, I could train the neural network by saying, here's a bunch of images, classify them between cat and dog. But there are so many other ways you could train this. Right? I could, for example, this is a lot more convoluted, I know, but bear with me here. I could, for example, feed it 3 images, 2 cats and 1 dog, and tell it, don't try and classify, just project them into this space and make it so that your projections are closer for the two cats and further for the cat and the dog, right? And that would make it so that we could have this neural network that, even without needing to classify, can just project images into this space where more similar images are grouped closer together. In this case, all the cats in one cluster and all the dogs in one cluster, right? Training objectives are of vital importance to training your neural networks. And it's not just about neural nets. It's not just about machine learning. It's about human behavior too. I feel like universally the rule for pretty much everything is be as lazy as possible. And I know that sounds weird, but that is pretty much true. Humans will try and find the easiest way of achieving a goal, no matter what the stakes might be, no matter what, the domain is. People will find the laziest way out to a certain reward or a certain goal. A friend of mine, Tim Duncan, he writes a lot of really interesting blog posts. One of them, A Tale of Two Police Departments, covers how the US Grant Office created grants that incentivized police departments by the total number of arrests that they made. And you can kind of see what the logic behind that is if you really try, in order to, help make it so you incentivize police departments to catch criminals. But then eventually you start to realize that you're not really incentivizing them to catch criminals in particular. You're just kind of incentivizing them to make as many arrests as they possibly can, right? That becomes the objective because that's what leads to the reward the easiest. That's the one that requires the least amount of work. And neural networks are obviously no exception. As a matter of fact, they are much more easily susceptible to this sort of bias because they're just large mathematical optimizers. It's a single large black box that you're optimizing using relatively primitive calculus. That's what you're doing. And so you have to realize that your training objective isn't telling the neural network what to learn, it's telling it how to learn, right? It's not telling the neural network tell the difference between cats and dogs because this neural network isn't a human. You can't explain these sorts of things. It's telling it how to learn down to a mathematical level. And it just so happens that the set of numbers that it comes to is good enough for the distribution of data that we're feeding in that we use it in production use cases, right? That is what is so very important to realize about deep learning. I remember, quick story, one time I was training a spam detection neural network. I was working with the Stack Overflow team for spam detection on Stack Overflow. They currently have a system called Smoke Detector. Back then, they, of course, and still today, they have this thing called Smoke Detector to detect spam on Stack Overflow and automatically remove it. And I was working on a deep learning powered system to do the same thing, but more intelligently, so you didn't need to have manual regular expression rules and things like this. And it worked very well from a stats perspective, but when you would actually apply it in the real world, it was terrible, right? And it turned out that the reason for it was because, in general, like on average, spam messages were really short, but actual messages were much longer than the spam ones. Or even the other way around, spam could be incredibly long or incredibly short, and those messages were, usually in the middle. So the neural network didn't end up learning to tell the difference between spam and actual questions. It just looked at the length of the message. That's all it did. And so because neural networks don't learn things, they just move in certain directions in a very, very high dimensional space. In OpenAI's case, maybe hundreds of billions of dimensions space. You've got to be really careful training them. And that was definitely a big challenge with AutoLyricist. But that was just a very brief sort of introduction to how neural networks and how deep learning systems work. If you have any questions regarding that specifically, I'd be happy to delve much deeper into any part of this, or maybe even show you something if you'd like to, see something with TensorFlow or a specific demo. But one more thing that I do want to say before I go ahead and pass it over to sort of questions is that when it comes to applying artificial intelligence technology, of course, AI is almost a buzzword. I mean, it pretty much is a buzzword, right? So it's blockchain and quantum computing and IoT and all these other things. People try and throw these words onto practically every startup startup idea they can come up with, right, to try and get funding for things. But really, if you take a look at technology and what it's all about, right, I believe that fundamentally what developers do is we use technology to solve humanity's problems, right? And as we're using technology to solve humanity's problems, what's important to realize is that with something like AI especially, you should never work backwards from the technology to the solution. You should never say, hey, we've got AI, let's do something with it, right? Your focus should always be on, here's a problem, how can we solve it? And now just realize that the scope of the kinds of problems you can solve and how you can solve them has been greatly increased and widened because of the fact that you have this brand new AI tool in your tool belt to be able to analyze unstructured and structured data. Whereas, a couple of years ago, you'd be very, very limited in terms of what sorts of data you could process, what sorts of data you could analyze mathematically or with computers. So now, without any further ado, let's go ahead and take a look at questions. Again, if for some reason I can't get to a question today, feel free to contact me on any of these social media, and I'd love to go ahead and answer that for you. But yeah, let's go ahead and answer any questions you might have. All right, so I'm not sure if I believe Stefan would be coming, or Layla, yeah.
Yeah, I think Stefan will be joining soon, but thank you so much for an amazing, incredibly engaging presentation. I know we have a lot of questions here that Stefan will help us get through in the Q&A panel, and everyone feel free to keep them coming. I think I will have to turn presenting mode on for Stefan. And I think we should be good to go. We'll give you a bit of a break here, Tanmay.
Yeah, this happens. I think one of the longer talks I did, actually one of the longest, was like a 3-hour workshop
Wow.
in India, like an IIT or something, and it was pretty fun, but it was super interactive, so it was nice.
Well, we'll have to get you back for a 3-hour one soon then.
I'm looking forward to it, hopefully in person.
Sounds good.
All right. Perfect. So we'll get started with our first question. I actually don't think we're going to have time for all the questions, so we'll select a select few. When writing music, you have to blend the lyrics into a rhythm. Does AutoLyric have the capability to start to create this kind of flow? If not, do you think this could be implemented into future versions?
So as of right now, it does not. However, that comes with an asterisk. And the reason I say that is because this neural network learns things that you wouldn't expect it to learn. And at the same time, there is the potential to be able to insert that information in the future. So first of all, major problem with, I think, everything nowadays is data. Even just gathering lyrical data was hard enough. Had to write custom scripts for grabbing data from various online lyric sources. Also, what's really interesting, and I don't exactly know why this is the case, is people can't seem to agree on lyrics. There are certain songs where Genius, Google, and other websites will have different versions of the lyrics. And it's interesting training a neural network when you can't even have a ground truth of data that can agree with itself, especially at large scales. So gathering lyrical data was difficult enough. Getting lyrical data alongside musical data would be even harder. Feeding audio into neural networks is incredibly compute intensive. However, it is possible to be able to align musical and lyrical data. Really quickly, one thing is that I have noticed that the neural network is capable of deriving some of that information implicitly from the way that previous lyrics are structured, right? The idea of the neural network is that you feed it, for example, like a verse or a chorus that you might already have, and then it generates practically infinite of however many other sections you want. But because of the fact that this is a neural net, not a human, and it's not just looking at raw text, but also using that text to derive other information, it does end up learning some semblance of what the sort of rhythmic structure of the music would be that goes along with those lyrics. So it does learn a little bit of that. So it is sort of coherent. However, in a future iteration, that's definitely something that I could work on.
Cool. Okay, next question. Is there a way for students like us to work with or use this AI?
Totally. So it depends on which one you're talking about. So if you're talking about like AI in general, I think like working with machine learning technology, there are lots of great ways to get started. Of course, there's my book Cognitive Computing Through Watson that I absolutely love. Right here, I've got a copy with me, of course, and it's a really interesting way of getting into the world of machine learning technology without needing to know how all of it works on a low level to begin with, sort of get an idea of what the capabilities are. From there, I would recommend using resources like cognitiveclass.ai is a good one. There are all sorts of different, beginner courses like machine learning and data science with Python that you can take a look at for getting into the world of machine learning and AI. In terms of these specific projects, if you'd like to, use these, components of Hard ID are available on GitHub as open source for you to use yourself. Auto Lyricist isn't yet due to licensing issues, but a version of it will be soon, is the idea. So working on it. But if there are sort of more specific areas that you would like to sort of use, feel free to let me know. In terms of resources to actually experiment with machine learning technology, I do know, for example, Google Colab is a great way to get started with machine learning. That's something that's it's an interesting platform, right? It gives you lots of free compute for training machine learning systems, which kind of is necessary today with how compute intensive neural networks have gotten, as well as different resources like Kaggle to get data sets that you can use to train your neural networks or take up certain challenges. So those are a couple of resources on a high level. Of course, there are more. Like, for example, my YouTube channel, I have a Learn Deep Learning from Scratch series. Coursera is a great way to get started as well. I know the teams behind some of the courses on there for AI material, and I know that their sort of deep learning specification and sort of learning path is great as well. So I'd say those are a couple of good resources to sort of get started with machine learning and AI.
Here's a popular one. Is it possible to integrate the Heart ID into a phone's pulse sensor and use it in a day-to-day life as we use Face ID? And would it be able to match the speed of those recognition systems? And if so, are you planning on doing so?
It's really interesting, first of all, the way that phones detect your heart rate, because the way that, like, for example, the Apple Watch does it, or the way that a phone would do it, is, basically what it does is it reflects light onto your skin, and it looks at variations in the brightness of the light that's reflected from your skin. I remember back when I first learned some basic computer vision, right? That was one of the first things that I did, was I took a little video of me sort of like covering the flash on my phone and sort of holding it up to the camera and recording that, and then trying to use that to calculate my heart rate in Python. It's a pretty fun little project. You should try it. But the problem with that is that only gives you raw heart rate and not enough fidelity to be able to do identification. Heart ID works on electrocardiogram, which does require some dedicated circuitry, but it's honestly incredibly simple. You might have seen, I unfortunately don't have the actual thing on me right now, but you might have seen in the video, for example, it's just a tiny little board, and I'm sure you could miniaturize it even further to just basically require the electrodes. It would take basically no space in a phone. So it is theoretically possible. Only thing is, though, that currently the way the system works, you need to capture data in a way that doesn't capture noise from your muscles as well, right? Because movement, that's also electrical, that will capture some noise. One way to get around this is to use 3-lead ECG, but unfortunately it was a little bit infeasible to, for example, go on stage and say, in order to test this out, or even just like in a data center, if you're using this for authentication, to say, hey, take off your shirt so we can identify you, right? So it's kind of infeasible, but it is possible to integrate these into platforms like a phone, or a smartwatch is actually more applicable. The Apple Watch, for example, can already capture ECG. Matter of fact, I wanted to implement this as an Apple Watch app, but Apple doesn't give you access to raw ECG data, unfortunately. But soon, eventually, when they do give you raw access to that, I might just port this to the Apple Watch and make it available as an app. So soon, it is possible. And unfortunately, while I'm not like a hardware guy, I don't plan on doing this as of right now. It is something I'm looking into. So it is possible.
Okay, another question. Do you think it's possible to achieve artificial general intelligence using neural nets?
Great question. One of the most common questions I get, actually. And every time I have a slightly different way of approaching it, because it is such a fascinating topic to topic to dive into, right? And I'm going to try and keep this brief. On a high level, basically, I would say no. we cannot achieve the kind of artificial general intelligence that we think of using just neural networks, because neural networks are static, right? Even with, for example, a reinforcement learning, the models with which you inference are inherently static and very limited in their capacity to learn things, not only from a perspective of how many weights can you fit, but also a perspective of how we train things. The fact that we treat this as one big black box to optimize, right? That is so foreign to the way that any intelligent system works. And as of right now, we only know of intelligent systems that are organic, right? It's so far-fetched from how any of these work that putting sort of being able to emulate artificial general intelligence with AI would require a fundamental rethink of all of the math that goes behind neural networks to something more reminiscent of trying to emulate the actual chemistry of a brain, right? Now, there's different arguments to this, of course. Or there's different sides to the perspective of whether or not you can achieve AGI with a neural net. I would say no, according to the capabilities that I've seen and sort of the technology that I've worked with and the limitations in particular that I've seen. And also because I feel like we as humans have a tendency to way overestimate how intelligent things are, right? Like, classic example. This one's a really fun one. This is a roller coaster. There's been this like news going around. It was a little while ago, at least, of Facebook AI research trains two chatbots that start talking to each other in their own language, and they had to shut it down. And I was like, no, I've read the paper. That's not what happens. It's not how this works. In particular, let me tell you what was happening, actually. They trained two language models on English to generate data, and then two neural networks to sort of use that language to sort of trade between each other to make it so that they both maximize value by bartering with each other in English. And eventually they made it so that, hey, why don't we let them optimize the language model too? And obviously when you do that, you're going to have them optimize the language model so you use less words to get across the same point. At which point they're not human, so they have no need to stick to any of our word ordering or vocabulary, so they end up creating effectively a custom token sequence that they use to barter. That's not chatbots communicating with each other in their own language that they have to shut down. That's an optimization problem that had no applications in production, so it went nowhere. So it's, people very much overestimate the intelligence of things. And I think our belief of neural networks turning to AGI is also part of that. We overestimate how intelligent things can be. So I would say no, personally.
That's funny. All right. I think we have time for, let's say, 2 more questions.
Sure.
The next one is, how much time do you spend on projects in a week or month? And how do you make time for everything?
It's a great question. It's really, I have fun doing this. You'll ask, if some of my friends, for example, they'll be, they'll talk to me randomly. Like we'll be on Discord, for example, and I'll just be working on something completely random, and it's just because I find it enjoyable enough that I spend a lot of my time, pretty much all of my free time, working on these sorts of things because I find that enjoyable. I remember Autolyricist, and I think this also answers another question too. Autolyricist in particular took me a couple of months in total to build out. I'd say like 2 months to get like one prototype out, and then like 6 to get like an actual like new version of it out that was more coherent and used different neural networks. And throughout that time, it was more of, of course, I do have, other work that I'm doing and talks like this one, for example, stuff like that. But it's really just, I find this enjoyable enough that I'm spending good chunks of my day working on these sorts of projects, hours on end, just because it's fun, seeing neural networks getting trained, watching that loss value decrease in TensorBoard, it's classic, waiting for those neural networks to converge. So I'd say I find it fun enough that I'm spending, good chunks of my day working on this sort of stuff. I remember once I had one of my friends make me write a neural network in ARM assembly from scratch because I thought that would be an interesting way to learn ARM assembly. It did work, by the way. I just didn't get around to the data loading logic, but apart from that, it did work anyway. But yeah, I find this stuff fun enough to spend good chunks of my time working on it, and balancing it is sort of natural in that sense because I spend my time doing it. There's no specific strategy I have.
Yeah, creating a neural net in assembly sounds sounds pretty intense. All right, last question.
Yeah.
One of the hardest parts about developing anything with AI is the data mining and collection. So how would an individual get around to that and access data that isn't publicly accessible?
Right. That has been a focus around a lot of different talks that I do around AI not being accessible and therefore, competitive, anti-competitive behavior almost being sort of intrinsically built into the way that AI works because it requires existing data, right? Like I remember, and people will disagree with me on this, but because this is subjective, but in general, Spotify's recommendation algorithm has been superior to, like, for example, an Apple Music. And the reason for that is because they just use way more complex algorithms, and they also just have a lot more streaming data to use. And that's why, like, for example, in a lot of regions, Spotify, still does, even with Apple users, have a much, or used to at least have a much larger user base. Right? They could put up that sort of fight against an Apple ecosystem level threat because they have really good machine learning. And really the only way to work around these sorts of issues is to put together data yourself in a way and try and use techniques that get around the need for a lot of data, right? Like, for example, GPT-3, having been trained on so much general purpose data, can make it so you can do a lot of natural language tasks zero shot without training, right? You can feed GPT-3 with a prompt for something interesting and have it just continue it, even if it was never explicitly trained on it. Similarly, if you're trying to write a neural network to classify between different musical instruments, maybe you could start off with something more open-ended, like ImageNet, train a neural network on that, download existing weights, whatever, then fine tune it to something like Stanford's people playing musical instruments dataset. That's a little bit more specific. Then maybe you go ahead and transition it to your own custom smaller dataset that you've put together yourself with a small team. And you train that fine-tuned neural network further, right? So there's algorithmic ways of being able to overcome a need for a lot of data. There's ways that you can put together data yourself. You can crowdsource it. You can use places like Amazon Mechanical Turk or Crowdflower to put together the data set for you. And of course, you can use things like the Google Dataset Explorer and Kaggle to also try and find auxiliary data. But really, it's about being creative with how you solve the problem, right? Deep learning is an art, not just a science. So it's all about trying to come up with a way to solve that problem. So that's that.
Perfect. Thank you so much, Tanmay. It was great having you speak with us here.
Of course.
For anyone who wants to rewatch or had missed portions of the talk, Windsor, I'm sure UTM, and also McMaster are going to be uploading the recording of this event to our YouTube channels. And Tanmay, for anyone who wants to hear more about you, how can they hear more?
Definitely. Feel free to, of course, I showed my contacts out a little while ago. You'll be able to find that in the replay. Feel free to email me if you have any more specific questions. You can take a look at my LinkedIn or my Twitter as well, or of course my YouTube channel where I do upload new updates and fun things that I'm working on. So, feel free to reach out to me there. I'd be glad to get in touch. I'm not sure if, any of you are in like the Discord server that we're in around this event, the GDSC sort of community. So if you are, feel free to message me questions on there as well. And I'd be glad to answer anything or have any discussions you might want to. So yeah, looking forward to it.
Thank you so much, Tanmay, and thank you everyone who showed up today. We'll be posting the recording soon, hopefully.
Yeah, just keep an eye out on all 3 of the YouTube channels, DC McMaster, UTM, and Windsor. It should be available there. Thank you guys for showing up, and thank you so much, Tanmay, for coming out to this talk.
Of course. Thank you.
All right, everyone, have a good night, and we'll stop recording. Thank you so much.
Bye-bye.